This material, which you have seen and probably touched many times, was one of the most important discoveries in our history as humans, since it fueled the Industrial Revolution in the 18th and 19th centuries. This allowed us to enjoy many benefits that we take for granted today, like automobiles, electricity in our homes, industries, and many more areas that require energy. Coal was a very good source of energy back then, coming from organic matter that has been in our Earth for hundreds of millions of years. Back then, only about 2 centuries ago, it was the best we had. But as you have noticed, we have evolved a bit in these 200 past years. The coal era is luckily declining and disappearing due to many factors that we will explore in this video. We will see why it's bad for humans and for the planet as a whole. Then look at better energy sources, and finally, we will examine the best form of available energy right now, which is still controversial to some people. But if we put aside emotions and media influence, we will show how nuclear energy is by far the best option. Coal is still the largest energy source in the world, with around 33% of electricity generated from it. The process of extracting energy from coal is as follows. Once coal is delivered to the plant, it is grounded into a fine powder to increase thermal and energy efficiency. This powder is fed into a furnace where it burns at around 1500 degrees Celsius. The immense heat found within this combustion chamber will end up heating the water in an adjacent tank, heating this water up to its boiling point. Then, once this water gets converted to steam, it is driven by huge and large pipes towards the true, tried and tested method of creating electricity, a mechanical turbine. Here, the kinetic energy of the hot steam gets converted into mechanical energy, spinning these long and very heavy steel turbines to a decent amount of RPMs. Finally, the turbine itself connects an axle to a generator to turn that mechanical energy into electricity for distribution into the grid. But the exhaust gases of the coal combustion itself are carried out through pipes toward these smokestacks, where they end up releasing sulfur dioxide, nitrogen oxides, unburned particles, carbon dioxide, and heavy metals like mercury, arsenic, chromium-6, and many more. These compounds cause diseases and cancers. It is estimated that around 250,000 people die each year just from coal energy production. In the US alone, between 1999 and 2020, there were 450,000 direct deaths from coal-based energy. Burning coal represents 76% of all CO2 released in the power sector and 45% of global fossil fuel CO2 emissions, making it number 1 in 2024. Many health issues that people suffer today, which they can't control, come directly from coal combustion. Next on this list, we have natural gas plants. These work by transporting methane or CH4 through national or international pipelines to the plants, where it is used as fuel as the same way coal is used, although they are more efficient for a little fact that I will mention in a second. The methane gas is put into a combustion chamber and ends up heating nearby water tanks. Then the hot steam is driven through the pipes to spin the very heavy turbine. The efficiency part is that some gas power plants use a combined cycle where the hot gases from the combustion are also used to spin turbines the same way as water vapor does, thus greatly improving efficiency of these plants in some cases. Compared to coal, natural gas produces about 45% the CO2 that coal does, and much less sulfur dioxides, nitric oxides, and particulates. Still, natural gas generates about 24% of global electricity, second only to coal. It accounts for 20% of global fossil fuel CO2 emissions, a better option than coal, but still not great for the long term. And then we find renewable energies. As their name says, they are considered infinite, quote-unquote, since they are resources that would not run out, the most popular being hydroelectric power and its way of working is simple and similar to coal and gas plants. The dam itself has a floodgate in the rear part, and once it is open, the water can go down with the force of gravity and easily spin these turbines, which in difference to other power plants, this turbine is made in a vertical array, meaning that the turbine itself goes up and the generator is on the top floor of the dam itself. The force of water is the coal and gas in this case. Now, even though hydroelectric power does not release amounts of greenhouse gases, heavy metals, or many various pollutants, it does bring with it particular disadvantages of this energy, such as the construction of dams in rivers creates reservoirs, which alters local ecosystems, blocks fish migration routes, and alters the water flow. The water temperature changes since it stagnates, and the fauna of these rivers is very sensitive to temperature. The organic matter and sediment from the river thus go to the bottom of the reservoir, rotting and releasing pollution throughout the entire body of water. Reservoirs can be sources of methane, a powerful greenhouse gas, due to the decomposition of organic matter at the bottom of stagnant water, although its impact on the global percentage is quite minimal. Dams trap sediments which can affect the health of rivers and coastal areas downstream. And finally, the size of dams is on average massive. And if we take all the water space they use, they are ridiculously large, which usually happens with renewable energy sources that we will mention. Even so, hydroelectric power represents 16% of our global energy, being the largest source of renewable energy. Then we have solar energy and wind energy or wind power. These two account for 13% of global energy, wind being around 8% and solar being around 5 to 6%. Wind energy is the simplest. Since the wind spins turbine itself, the kinetic energy of the wind gets transmuted into mechanical energy in the spinning turbine itself. And then, as in the previous cases, it gets converted into electricity by this generator. And then, through these copper bundle structures, it gets sent into the grid. Solar energy works in a different way. Since the silicon in the solar panel gives a photovoltaic effect, that is, when the photons of sunlight hit the silicon, they are absorbed and then release electrons, thus creating electrical energy, which is directed through the copper of the panel. Since electricity is the flow of electrons through matter, it is created instantly. These two sources are relatively good and green, but both have the same problem, their variability. That is, it is not windy all the time, and it is not sunny all the time. Thus, their operating window is much smaller than the previous methods. In addition to this, the space required for these places is usually massive, which for large countries it is not much of a problem, but there are many small countries, like in Europe, that have these methods, thus being a bigger problem for them. Then we possess other problems, such as that solar panels contain toxic materials like lead, chromium, and cadmium, which can leak into the soil and groundwater if not properly disposed of. Also, solar panels have a limited lifespan, and all the solar panels in homes and solar farms will need to be replaced every 30 years or so, thus creating many thousands of tons of solar panels around the world. And then we have problems such as bird species, which sometimes crash into wind turbines, thus killing several millions of these animals around the world. Without a doubt, these two relatively new energies have their place, especially solar energy for people who live in places where the energy from their country tends to be very expensive. Anyway, now we will see what is the best energy source we currently have, and we will also touch on what would be an even better one, maybe for another video. Nuclear energy, specifically by fission. I will keep it very short on this one, since I got a lot of nuclear videos coming and planned, but essentially, in a nuclear power plant, uranium atoms are used as fuel. When these atoms are hit by neutrons of uranium, They undergo fission, meaning they split apart. That in and of itself is fission. These neutrons carry with themselves a lot of kinetic energy, and when they hit the surrounding water, they end up heating it. The heat produced from the fission reaction is used to heat water in a reactor vessel, turning it into steam, just like in coal or gas plants. This steam is then sent to spin turbines, which eventually generate electricity. But to add a bit more content, in nuclear reactors, several so-called nuclear fuel rods are grouped together so that the chain reaction is greater and more efficient. Around all these rods, we find water, which acts as a moderator and coolant. Since if this water were not present, the high-energy particles released by fission would end up escaping and not triggering more criticality, thus halting the reaction. It is also to protect you from fission not reaching your body, that is neutron radiation. Okay, so when uranium-235 fissions, it releases neutrons. These neutrons release heat, which heat up the water inside of the reactor vessel. This water is then handled by a hot water pipe that turns into water vapor, and then this steam spins turbines and thus generates mechanical energy that is converted into electricity by a generator, as you already know at this point of the video. The benefits of fission is how energy dense uranium is. In some cases, enriched uranium is up to 3 million times more efficient than coal. That is, 1 kilogram of uranium-235 can equal 2.7 million kilos of coal. That is a gigantic argument in favor of uranium. But this is only the case for HEU, or highly enriched uranium. Since the birth of large-scale coal power plants, around 80 million direct deaths have been recorded. In comparison to these, the two biggest nuclear accidents in history, Chernobyl and Fukushima, have caused around 6,000 direct deaths estimated. Let's compare 80 million with 6,000 deaths, and let's remember that these nuclear deaths have been due to accidents and due to a tsunami. If these two accidents had not occurred, the death toll would be pretty much almost zero. The reasons for the fear of nuclear energy are usually the bad press given to it. It gives the impression that nuclear plants are the most horrible and dangerous places a human could be in, that you would be vastly shortening your lifespan, but as we already see with the data presented, this data is used by our governments to continue using other energy methods, which are much more deadly, and one of these reasons is the cost of nuclear plants. Nuclear plants are the most expensive energy sources that exist today, a single reactor costing around $5 to $10 billion on average. On the other hand, coal power plants cost around half to a third of what a nuclear power plant can cost. Most of the expenses of a nuclear power plant are made upfront for the construction of the plant itself. Once it is finished, the maintenance cost would be minimal in comparison. Let's do some quick calculations. Each nuclear reactor generates an average 1 gigawatt per hour or 1,000 megawatts. This number is enough to serve 1.5 to 2 million people. Let's take the lowest number to be safe. If we wanted to replace the United States, we would need around 230 reactors throughout the country. If we put 3 reactors per plant, it would be around 75 plants in all 50 states. And with this, we could eliminate all other power plants that are not nuclear. Being pretty much close to 100% nuclear, we would need around 4,500 to 5,000 nuclear reactors divided into around 1,500 plants to serve all the energy of the entire planet. With the sole argument of saving lives and protecting the planet, we already have a big point in favor, since nuclear energy doesn't release any toxic gases and or greenhouse gases into our atmosphere. We always take what happened in Chernobyl and maybe Fukushima as an ultra-negative perception of nuclear energy, but we never take the disasters and the millions of lives and illnesses already caused by fossil fuels used as energy, as well as the several large-scale accidents like Chernobyl that have happened with fossil fuels. So let's look with logical eyes at the best energy source we currently have, and let's not be influenced by media and governments that only want the best for a select few and the worst for the vast majority. The worst in this case being millions of human lives lost and climate change, and the least bad being that they can save more money. You are the judge here. Despite this, a new energy source is being built as I speak in this video. This one is nuclear fusion. This will be the next step into having almost infinite clean energy.